Okay, good evening, everyone. So let us begin. Are there any queries from the previous session? I hope you are able to see my screen. Okay, great. So let's get started. We'll do a brief recap of what we did in the last class, and then we'll move on to the concepts uh, that were covered in this week. So we have covered a lot of topics till now. So I always like to keep all these topics here so that we are progressing. And we'll do a brief recap of all of these concepts towards the end of this course. Okay. So there is, I think, some of these libraries which we have not covered. I think SciPy was not covered. So I'll make sure that we'll cover this library in the subsequent uh, sessions. So please wait for that. Okay. So in today's session, we'll do a brief recap of recursion. And then we'll move on to seeing some basic application of Pillow Library or PIL. And then we'll see some applications of Turtle Library. And we'll move on to GMplot library and briefly touch upon CSV library. We have already seen this, but we'll see it again. Okay. So are there any queries relating to any of the concepts that were covered uh, relating to recursion in the last session? We'll we'll solve some problems. So I have the codes for different problems, the iterative as well as the recursive version. Okay. So I assume there are no queries over here. Okay. So let us move on to Colab. By the way, for those of you who are joining for the first time or who might not be aware of, so I'm uploading all these material, whatever I'm using, to the shared drives folder. So you can access all this Collab notebook as well as the slides that I'm using, which contains um, questions, problems, and their solutions. So you may refer to them at your convenience later. So let us see what we saw in the last class. So we saw recursion in Python. So recursion is a general concept that is applicable uh, in general to any programming language. So in Python, Python does support recursion. So recursion is nothing but a function calling itself with a certain base case. For example, okay, let us skip this max for now and we'll discuss the factorial one be earlier. Okay, let me close this as well. Okay. So in the last class, we saw like you can call a recursive function, a function within itself, and also you need to have a base case so that that recursion stops at a certain point. Okay, without any base case, your code will run into infinite loop. Okay, so and also we discussed a few things that in certain cases recursive code might be easy to understand than the iterative version or the other way around. Like the iterative version might be easier to understand than the recursive one. So we'll see those examples now. So with the very basic example that I'm going to discuss over here is the factorial example. So as most of you know, uh, n factorial is equal to n into n minus 1 into n minus 2 and so on up to 1. Okay. So this can be considered as n into n minus 1 factorial. Okay. So this has there is a possibility of having recursion in this computation. Okay, so you need to identify first the recursive relation in this equation. Sorry. Now, once you have identified that, so you'll have to write a base case. So what is the base case here? Once the value of n is 1, you'll have to return 1. Okay, so that is the base case. It can be the 0 or 1. It depends on sorry. Uh, so as we discussed in the last class, even 0 factorial is also 1. So it can be either 0 or 1, anything. So we'll stop at 1. Then as soon as you see that it is 1, you will return 1, and then else you will return n into factorial of n minus 1. So I have named this function factorial recursive. You can name it any way, whatever way you want it to be. So you can name it as fact or factorial or recursive factorial or so on. Okay. So n into factorial recursive of n minus 1. So let us run this. So this is just the definition of the function. We'll have to call it. Similarly, this is an iterative version of the same recursive code, like this particular recursive code over here to compute factorial. So what we are doing over here, we are storing result. So there is this final result. We are initializing it with 1, and then from 2 to n plus 1. So why we are going to n plus 1? Because range gives value till whatever end point you have over here, minus 1. So we want to go from 1 to n. So here what we are doing, we are multiplying this result with itself. So we saw in the previous session this particular operator. For those of you who don't remember, so this is equivalent to result equal to result into I. Okay, so this is a short form of writing result equal to result into I. So result into equal to I. Similarly, if it were plus equal to, it would have been result equal to result plus I. Okay, so it's that simple. So what we are doing over here, we are taking result as 1, and then we are multiplying. So so we are iterating over 2 to n, and then we are multiplying each digit over here with the result and storing it back in the result. So it will be 1. In second iteration, it will be 1 into 2. In the third iteration, it will be 1 into 2 into 3, and so on. Means the results get stored in this result variable, and then you are multiplying it with the next number. Okay. So let us run this codes. So I'll run factorial recursive and call it with file. So you see the output of both the functions is the same. The only difference is that in this case you are trying to go in an iterative way without calling this function again. And in this case you are calling this function again. Okay. So this is a simple example. So are there any queries in this? Is it clear, everyone? Yeah, please feel free to ask even if it is a basic query. Okay, great. Yeah. So this was an example of factorial. So let us now see Fibonacci series. So in this case, we have recursive as well as the iterative version of Fibonacci series. So as we saw in the previous session, if n is less than or equal to 1, the base case in the Fibonacci series is like if it is 0, then it will return 0. If it is 1, it will return 1. And then it will return Fibonacci of n minus 1 plus n minus 2. So here indexing I am assuming from 0, but you can take it from 1. So in that case, you'll have to define explicitly like if n is equal to 1, then you have to return 0. And if n is equal to 2, you have to return 1. So that you'll have to take care of. Here I'm assuming the indexing from 0. So uh, it was pretty straightforward over here. Okay. So uh, Fibonacci recursive. So here what we are doing, if it is 0 or 1, we are returning 0 or 1. Else, we are returning Fibonacci recursive of n minus 1 plus Fibonacci recursive of n minus 2. Okay. So let me run this. Okay. And then this is an iterative version of the same code. So if n is less than equal to 1, same, return n. Else, uh, you are initializing a and b. These are some temporary variables to 0 and 1, the first two elements. And then you are iterating over the next elements. Okay. And then this is another way of initializing multiple variables at a time. So here what is happening? B is getting assigned to A and A plus B is getting assigned to B. And then you are returning B. So it is doing the same kind of functionality as uh, can be seen over here, but this is just an iterative way of doing this. But can you see that this is much easier to understand than this particular code over here? So this is an example wherein like Fibonacci, I mean, like recursive code is easy to understand, although it makes some unnecessary function calls internally. But from the point of view of understanding the code, this is simpler than this iterative version. However, the iterative version is pretty fast because it doesn't make this unnecessary calls like the recursive code. So these are like some pros and cons of recursion over iteration. So is this particular part clear to everyone? Okay, great. Yeah. And here is another example wherein the iterative code is easier to understand than the recursive version. Now this is an example to find maximum element, maximum of all the digits or numbers in a given list. Okay, so I have a list and I have to find the maximum. So in Python there is a direct function called max. You can simply run it and it will give you the maximum value in this particular. Sorry, so array was not initialized. Array, it is taking the array, the previous array. Let me just take this array itself here. Yeah, so the maximum value in this particular array is 9 over here. So easiest way, if you want to go the iterative way, like one element at a time. So how will you do that? Uh, okay, without seeing the code, can somebody answer, like unmute themselves and answer? So what will be the correct way of, like, easiest way of finding the max element in a given array or list? Anyone? Yeah, please try to answer. Let's say I'm giving you this array and you have to write an algorithm to find the maximum value in the given array. So how will you do it naturally? Let us forget about some algorithm. So how will you do that? If I show you only one element at a time, like let's say like if I show you three, then I show you one, then I show you four, then I show you one again, and then I show you five. So how are you going to, say which is the maximum element? Anyone? Yeah, any guesses that is also fine. Like even if it is wrong, please try to answer. You can unmute yourself and answer.
Sir, question one more time, sir.
Yeah, so if I'm giving you this array and asking you to find the maximum element in that. So in this case, the maximum element is 9. Like the maximum value element is 9.
Sorting out.
Yeah, that is one way. Sorting out the array and then taking the last element or the first element, whatever way you are sorting. Yeah, that is a good answer. But is there any simpler way without sorting? Yeah, sorting is one answer. So I'm giving you a hint. Like I'm just giving you one element at a time. So I'm giving you three, showing you three. Then after that, I'm showing you one, then four, then one, then five, then nine, and then two, six, five. So what's happening? You're storing it in your memory, right? Like whatever elements you have seen so far. Okay. So you know that there is something. So I'm seeing three first. Then I'm seeing one. I know three is the max so far. Then I'm seeing four. Now I see that four is greater than three. So I'm updating my max element in my memory. Okay. So four is the max so far. Now then I'm seeing one. Then I'm seeing one. But I know that four is the max so far. So I go on to the next element. Now I see five. Now five is the max. Five is greater than four, which was max so far. So now I update the max so far to five. Then I go on to nine, and then I have to update max so far to nine, and then I'll go on to two, no change. Go on to six, no change. Go on to five, no change. So it's like you're just going through the array once. You don't have to sort it. You just have to have a variable max so far or max value till now, something, and then you have to just keep updating that variable. So it's that simple. Okay. So that is what is happening over here. So find max iterative. You're passing this array as an input. So this array is passed as an input to this function max. Uh, find max iterative, and then you are having this maxwell as array of zero. So first of all, this is the first element that I'm seeing, and that is the maximum element I have seen so far. So I'm initializing that with array of zero, and then for num in array. So for all the numbers in this array, I'm comparing if my current number is greater than this max value. If it is greater, then I'll update the max value. Okay, so that will happen till the end. So once everything is done, you will return the max value, whatever max value you have. Is it clear? Is it clear, everyone, what this algorithm is doing? So you're storing the maximum value seen so far in a variable called maxval, and it will contain the maximum value till the time you will reach the end of the array. Clear? Okay. If it is not, please let me know. I'll explain it again. But please answer yes or no.
Yes, sir, understood.
Okay, great.
Yes.
Yeah. So let me just run this code. So it is doing the same job as this max. Max is an inbuilt function in Python that takes any object, collection of items, and then gives you the maximum value as output. And we are doing the same thing as in an iterative way, seeing one element at a time. Now there is a recursive way as well to do the same thing. Now see this code. I want you to look at this code first and then try to understand what exactly is happening over here. And then we'll discuss it. Anusha, okay, let me explain it to you again. So Anusha, it's like let's say you don't have access to this part of the array. You only see this once. Okay. So far I have seen only three. So three is my max element. Now I see one. So I compare if one is greater than three or not. No, it is not. So I'll keep my maximum element as three. Then I go on to four. Now, 4 is greater than 3. So I'll update my maximum element to 4. This whatever maximum value element I have seen so far is 4. Then I go on to the next element. It is less than 4. No. So then go on to next element. Oh, okay. It is greater than 4. So I'll update my maximum element. Maximum value element. Okay. Now I'll go on to the next element. Then it is greater than even greater than 5. So I have updated the max value to 9. Then I go on to the next element, which is less than 9. So no update. Go on to the next element, less than 9, no update. Go on to the next element, less than 9, no update. So finally, my max value will contain 9 and I am returning that. So that's the same thing happening over here. So array of 0 will give you 3. You're storing that in max val and then you are iterating over every element in this for num in array. So you'll get 1, 1, 1, including 3. Okay. So if num current number is greater than maxval, then I'll update the value of maxval to the current number. Else I'll just leave it as it is. Okay, and then finally, after all this looping done, I'll return the maxval because maxval will contain the maximum value in the array. Is it clear? Anusha? Okay, great. So for others, yeah, sorry. So this is the recursive code of finding the maximum element in an array. So I want you to, look at this and then try to understand what exactly is happening. And if somebody understands this, can they, try to explain what they have understood? Yeah, please take some time to understand what exactly is happening over here. So I'm using the inbuilt function in Python called max, which will give you the maximum of two elements. So I have one element here and another element here. So it will return the maximum of these two elements. Anyone here understood what's happening? We'll discuss this. Yeah, please try to think over it. It is actually very simple, but I'm just trying to make a point, which I'll discuss shortly, that how iterative version is easy to understand and the recursive one. Okay, so let me just quickly discuss this in view of time. So what is happening over here? So you are taking the last element in the array and then passing on this array with n minus 1 elements. So the array is being passed uh, completely, but you are saying there are n minus 1 elements left to be analyzed. Okay, so you are trying to find the max of this and the remaining array. Similarly, once this recursive call is made, you're trying to find the max of 6 and the remaining elements. Similarly, that till the time it reaches this last element 3. So once the value of n is 1 over here, it will just return this 3. So in one of the calls, this 3 will be returned, okay, and then the remaining element, that is 1. So now max of 1 and 3 is being found, so it is 3. So it will return that. Then in the another call, max of 4 and 3 will be found. Means as the recursion, unfolds, and then so on till the time you reach this last element n minus 1, which is 5. So is it clear, everyone, what's happening over here? And can you see that the iterative version is pretty cleaner compared to the recursive one? Everyone, is it clear? Shall I explain it again, the recursive version? Okay, Darshan, I'll just try to explain it again. So what's happening over here? So let me just add a text box here. Okay. So in the first iteration, in the first call, I'm passing this array and n. N is nothing but the length of this array. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements in this. Okay. So when I'm calling this, I'm passing this entire array with value 9 here. And first of all, it will be this condition will be checked. This is the base case. Okay. So n is not 9. So it will just return max of, sorry, what is the last element in this? 5. It will return. So array of n minus 1 will be 5. And then it will call this find max recursive again on this particular part. So I'm entering the entire array. However, this time I'm entering uh, 8 as the input because I'm interested only in this particular part of the array, not the last element. Okay. So I'm comparing, uh, you know, finding max of the last element and the remaining array over here. Similarly, once this call is made again, so once this is called like 3 1 4 1 5 9 2 6 5 with 8, so the n minus 1th element in this is this 6 over here. So it will try to find max of, sorry, 6, and the remaining part of the array will be passed again in that find max recursive. So with value 7. Similarly, so I'm not writing it over here. So it is calling actually find max recursion. Okay, so here it will be called with 6. Now, so on till the point you reach the last element here, 3, and you call it with 1. Okay, so once you reach this n equal to 1, this particular find max recursive will return that particular element, 3, here. And max of 3 and 3 is nothing but, 1 and 3. It will be like last over here. And max of 1 and 3 is 3. Then it will unfold and go on to the previous call. So previous call will also have this particular part, max of 4 and find max recursive with the length of array to be analyzed as 2. So this particular call is returning 3, and which is going back again to the previous call, and then you are comparing 3 and 4. So in this case, 4 is the max. So it will return with 4 as the max, and so on till the point you get 5 and the max of the remaining array, like the array to the uh, left of 5. So in that case, you will get 9 and 5 here. So max of 5 and 9 is 9. So that will be your final answer. I understand it is little difficult to understand, but yeah, once you try with pen and paper, it will be easy for you to, get it. So I hope you got something what is happening over here. Darshan, is that clear?
Sir, how that n value becomes 7, sir? Actually, we are not decrementing no, separately.
Yeah, yeah. You're not decrementing separately, but you're passing n minus 1 over here. So once you're passing 7 here, in the another call, the value of n will be 7. So once you're doing n minus 1, it will be 6 here. And then another call is being made with n equal to 6, and then this will be n minus 5, 1. Sorry, n minus 1 will be 5 over there in that case, and so on. So till the point this n is 2, so this n minus 1 will become 1, and then this base case will be called. Is it clear, Leela?
Yes, sir. So that in recursive, there is no need of decrementing. So it will automatically do that
Yeah, so
for
it will use the
every
current value
iteration.
of n in the function call. So since you're calling it recursively, so find max recursive with you're calling it with n minus 1. So this n will become this n minus 1 in that particular
Yeah,
call.
that not decrementing separately. In recursive, automatically it does that.
Automatically in the sense it will call this n
N
function
minus
with n
1
minus
means
1.
it's 8. For next time, it is becoming 7.
Yeah, so for next time in the sense this particular part.
Yes, sir. Yes.
Yeah. So it is like passing 7 here. So like I'm calling, let me just write it explicitly. So I'm calling it with 8, and when I'm calling it over here, it is becoming 7. Is it looking cleaner little bit here?
Yes, yes, sir.
Yeah. So then this function with 7 as the n value is being called, and then so on. And then when it is 7, it is becoming 6 here. So it is trying to call this function again and again, but with the decremented value of, n.
Yes, sir. Yes.
Yeah. So yeah, so I think now you get the point that in certain cases recursion is easy to understand, like in Fibonacci series, which is very clear here. But however, in certain cases it is, not so straightforward to understand what's happening over here. But yeah, it's pretty easy, not that difficult to understand, but that's the point I wanted to make. Okay, if it is not clear, I'll explain it again in the next session probably, but in view of time, I'll have to move ahead. So please let me know if you have any queries. Yeah, yeah, Tulsi. So that's what I mentioned in the very beginning. You can simply use max on the entire array in Python. That also works. This is just to show a demo of recursion and iteration. Okay, great. Okay, yeah. By the way, I'll be sharing this notebook with you, so you can also, make a copy. So for making a copy, you can just go over here, and then there will be an option to save a copy in drive, so it will be saved in your drive, so you can play around with this notebook, or you can simply just copy this code and run it in your system or Google Colab, wherever you are more comfortable. So yeah, you can tweak these values, you can change these array values here, and then play around with this code. So that will help you better understand what's happening over here. Okay. So So this was all about recursion. Then, yeah, there is one more algorithm that is left, that is binary search. So in the previous session, we saw, like we briefly discussed this, like how binary search is done. And one of the conditions that is needed for binary search to be done, applied is, can somebody mention? Like if I have an array of numbers and I want to,
It should be
uh,
already sorted.
yeah, that's correct. So the array should be already sorted. Yeah, that's correct. Somebody asked, can we access online later? Yeah, definitely, Tulsi, you can access all these recordings and the material online. Let me share link to the YouTube channel where all these session recordings are uploaded. You can also access it through the Swayam portal. So if you go to the Swayam portal, let me just go over there. Yeah, so you can find the problem solving session over here. And if you click on this, it will redirect you to Google Sheet, wherein you will find the links to all the sessions and then a link where to a drive folder which contains all the material, including the slides. So for example, the slides, the PDF version of the slide and the IPYNB, like the Python notebook that I'm using, the Colab notebook that I'm using. So you can download them and or you can, access it directly on your system and work with Colab. Okay, great. Yeah. So here are the iterative and the recursive versions of binary search algorithm. So as rightly pointed out, the condition for application of binary search is that the array should be sorted. Okay. And as you saw in the like as you look for a word in a dictionary, so you randomly go to the point and see if the word is before that or after that. Similarly, in binary search, you go to the middle point and then see if the number is to the left or to the right, and then you focus on only that point, that part of the array. Okay, and in that part of the array, so let's say this is the array over here, and you want to search, uh, let's say 3. So you go on to the middle element, let's say 9. Okay, in this case, there are even number of elements. So either you can have 7 as the middle element or 9 as the middle element. So it depends on your program. So let's say 7 is the middle element. Like I take the floor value of 8 by 2. Or okay. So I now 3 is my element that I want to search for. So 3 will be definitely to the left of 7 and not to the right of it. So I just discard this part of the array and focus on this array. Sorry, focus on this part of the array. Now the middle element here over here is 3. So now I compare if my middle element is equal to what I am looking for. If it is not, then I look into the other part of the array. Here in this case, it is what I am looking for. So I'll return that particular value. Okay, this is a short example. This is a short example. So, but in case of like a very large, array wherein you want to search for some element, Uh, so in that case, binary search is quite useful compared to the linear search that you would have otherwise done. Okay. So iterative version was like just updating this middle value. So, sorry. Yeah. So let me discuss the iterative version first, and then we'll go on to the recursive version. So earlier, I'm just setting the left and right to 0. Sorry, left to 0 and right to length of array minus 1. So left is over here pointing to 1 and right is pointing to the rightmost element. Then you compute while left is less than right, less than or equal to right. Okay. So you are moving this pointer. So this left pointer is moving this side, right pointer is moving this side. While left is moving less than right, less than equal to right, you're computing the middle element. So now you might be wondering why this particular way of finding this middle element is done. You could have simply used right plus left divided by 2. Okay. But this kind of helps you to avoid any overflow in Python. So what is an overflow? So each variable type, let's say integer, has its certain maximum value. For example, I'm not sure the max value of integer in Python. Let us search. Yeah. So this is, let's say, the maximum value of integer that can be stored in an integer type variable. Okay. So now, if I do some addition over here, so internally it will cause an overflow in the system because of which the correct value won't be calculated. Like, so that is like an overflow that is happening over there. So even if it is a max element, so let me go back over here. Yeah. So this right minus left will ensure that this is going to be less than that max element, and then you are adding this left to this divided by 2. So this is nothing but equivalent to right plus left by 2. So this is right by 2 minus left by 2 plus left, which is equivalent to right by 2 plus left by 2, which is right plus left by 2. But just that this particular part ensures uh, that there is no overflow happening. Okay, so simply you are just computing a mid element. So these are some programming tweaks that you may want to do in the big codes that you will be writing later. And yeah, so you're checking if the middle value is equivalent to the target, like whatever target you have. So in my case, I was looking for 3. So if the middle value is equal to 3, then I'll just return that mid value. Else, if mid value is less than target, I'll just update my left pointer. So in this case, so my left pointer was here, right pointer was here, and the mid value was 7. Okay, so the middle pointer was over here. Now I know that the target is less than the array of mid. So I'm just updating this left to this particular part, mid value. So my right is pointing over here to 1 and the left is pointing over here to 7. Okay. Now this is the array I'm concerned about. And then you will repeat this again. Okay. Till the time left is less than equal to right. Once this condition gets false, like if the element is not there in the list, okay, so left will move over here uh, toward the right, and right pointer will move towards the left because you are decrementing this left and right, or like incrementing the left and decrementing the right. So at certain point, if the element is not found, the left will become less than right. In that case, you will return -1. Okay. Else, you will return the uh, array of mid. So is this binary search algorithm clear? What's happening in this iterative version of the binary?
Sir, by finding length of the array floor division by 2 also will gives mid value, no, sir.
Yeah, yeah, length of array. But in this case, we are not considering the length of array. We are considering the pointer. So length of array is fixed value 9. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 8 over here. But your right and the left pointer are updating. So you are taking the mid of that particular. So let me explain it to you on iPad. Please give me a second. Okay, are you able to see my iPad screen?
Yes, sir.
Yeah. So what was the array I had? Like it was 1, 3, 5, 7, 9, 11, 13, and 15. So initially my left pointer is over here and right pointer is over here. Okay. So these are the index values. So left is 0 initially and right is 9. So I'm trying to find out the middle value over here. So it will be simply floor division of 9 plus 0 by 2, which is floor value of 4.5, which is 4. Okay, so this is simple. However, uh, now my search element was like 3, target was 3. So so this is my mid value now. So mid is pointing to 4. Oh, sorry, my bad. It should be 7 plus 0 by 2, floor division, which is 3.5, which is 3. So mid is pointing over here. Okay. Now I'm concerned only about this particular array, part of the array. Okay. Because I know that the search element is less than the array of mid. Array of mid. So mid is set to 3 and array of mid is 7. And my target, which is 3, is less than 7, which is array of mid. Okay. So I'm updating my right pointer over here. So right is now pointing to mid. So then I'm finding the middle element of this. And then so on, like repeating this step again and again. So let me show you in. So let's say I have multiple. So initially, uh, left is here, right is here. Then I go on. Let's say the element I want to find is this. So first of all, I find the middle value of this. So mid is somewhere over here. I compare if this value is what I want. No, it is less than that. So I am only concentrating on this part of the array. Okay. Now I update my so this was left earlier, right, and this is mid. Now I'm updating my right to mid. So this has become my right now. So this is the array of concern. Now I find the mid value again. And mid is the sense middle index, not the mid value. So middle index, and then see the value at that middle index. If it is greater than target, so no. So yes, I have to update my right. Then I'm concerned only about this particular part of the array. And then mid value will be found based on this. In this case, mid value is over here, which is less than this, the current value, sorry, the target value. So in this case, my left pointer will be updated. So then you go on to finding the mid again. It is not. So then in that case, your right will be updated and then you land over here to the mid value. And if it is equal to what you are looking for, then you return this. So is it clear, Leela, what we are doing over there?
Yes, sir. Now I understood why we are using left and right.
Yeah, yeah. So we are not considering the entire array length, but just the part that we are concerned about.
Yes, sir. Yes.
Okay. So now this was the iterative way of doing it. Like you're updating the left and right. But in this case, we have discussed what recursion will be. So in this case, what was happening? So searching this in entire, sorry, calling binary search on this entire array, uh, you see the middle element. If it is less than, the target is less than the middle value, you call binary search on the remaining. part of the array. Similarly, then in that further recursive call, you call the array, sorry, binary search on the remaining part of the array based on the middle value and the target. So let me go back to the collab version. So in the recursive call, you have array, you have left pointer, right pointer, and the target. Okay. So similarly as in the recursive code, if left is like if left becomes greater than right, so you return -1. That is the base case in the recursive call. Else you compute the mid value. If array of mid is target, as we saw in the you know iterative version, you return that particular mid value. Else if it is less than the target, you know that it should be to the uh, uh, left of that particular part. So you update the left pointer to mid plus one. Else you update the right pointer to mid minus one. So you are calling this binary search again with the remaining part of the array. Okay, just updating this left and the right pointer. Similar to what you are doing over here, left and right were updated iteratively in this while loop, but here you are just calling that function with the remaining part of the array with updated left and right pointer over here based on the value in the middle. Is it clear, everyone? What's happening over here? What about others? Is it clear? Yeah, somebody asked like if I can discuss assignment to yeah, I can discuss that, but is the person over there? Okay, I think the person has left. Okay, great. So this was all about recursion and iteration. So you will see a lot of other examples as we go along the course, like or otherwise, there are different algorithms wherein if you can identify the recursive relationship over there, recursive relation. So in that case, you can definitely write a recursive version of the code to compute or for that particular computation or algorithm. Okay, so let me just quickly run this, and both this iterative and the recursive version will give you the same answer. As we discussed in the previous session, one of the previous session, this f is a format specifier in which you can just use this curly braces to get the values in the string. Okay, so this target will be used as it is, and then the iterative result will be used as it is over here. Sorry. Yeah. So coming to the next part, which is Pilo library. So I just have an example over here. So let me quickly upload that file. Yeah. So I've just uploaded this file called example.jpg in this. So Pilo is a library in Python that is used to perform certain operation on images. So you'll find so I've given a link over here for Gigs for Gigs. So you can see more over here in this website. So like how you can, manipulate different images. So I'm discussing only few of these examples, but there are multiple ways in which you can, use this Pillow library. There are other libraries as well available in Python that you can use for computer vision application. But this is just a basic library that can be used. Okay. So forget about this particular part of the code. Um, First of all, I'm importing from this PIL. So Pilo is shortened to PIL. So the library name is PIL. It is called pillow, but you'll have to make sure that you import PIL. Okay, so from in this case from PIL, I'm importing these three submodules called image, image draw, and image filter. I'm not sure if everything is discussed in the class, but image is something that you might be needed uh, for most of the assignments. If there are any questions on this pillow library. Okay, so what's happening over here? So just forget about this particular function. I'm using this function only to plot the images in Colab environment because otherwise you would have simply used. I'll show you how you can do that. So image equal to image. So what I have used this image submodule to open a file. So this example.jpg contains an image. I'll just show you over here. So this is an image of a bird. Okay. So I'm opening that and storing that in a variable called img. Okay. So let me run this step by step for you. So I'm first of all importing this. Then let me just load this image. So if you want to see the content of this image, you can't do this directly over here. So if you just print img, it will show that it is a uh, PIL like pillow library object. So to display that, you can either use this img.show, but it doesn't work in Colab directly. So if you just simply run this, it won't give any output. So for that, I have written this particular function show image, which will use matplotlib library to plot this particular image. So let me just import this matplotlib.pyplot as plt, and I'm defining this function show image over here, which will take that image object, and then the title of the image I'm just giving as default image. Okay, so let me just call this show image with original image as the title of the image. Okay, so img is being passed over here. Then plt.figure will set a figure with size 5 by 5. So there will be a figure space of dimension 5 cross 5. In that, I'm plotting this image with plt.imshow. Imshow is a function in matplotlib. And then axis of means it will hide the x and y axis. And then title, I'm adding this title as image, whatever title I'm giving over here. So this is being overwritten by this original image and then doing plt.show. So let me just run this. So you can see over here that so I have this image with title original image and then the image of the actual image of the bird. I can write anything over here, anything. No. Okay, so it will override this and then display the image. Okay, till this point, is it clear? Later part is like very simple, like you just have to use some inbuilt functionalities of Pillow library. So we'll discuss that as well, but is it clear? Okay, great. Yeah, you don't need to bother about this. Like you don't have to remember this right away. You can once you go through it multiple times, you will get to know about it. Okay. So this is about yeah. So there are other functionalities as well here. So you can get the format of the image, like if it is JPEG or PNG or JPG or any other format. So this image object will contain all the information. So img.format will give you the format of that image. Img.size will give you the width and height of the image. sorry, img.mode will give you the mode in which the image is there. So if it is RGB image or RGBA image or grayscale image, for example, if it gives you L, so it means it is a grayscale image and so on. So let me run this particular part. So you see the image format was JPEG. So format is JPEG. Size is 1200, sorry, 1200 cross 1200, and the mode is RGB. It is the color image. Okay. And if you want to resize this image, so the size of the image is 1200 cross 1200, and I want to resize it. So I can use this img.resize and then pass on this tuple over here with width and height, and then let us do this show image. So you can see that this image is kind of shrunk to 200 cross 300. So 200 is the width and 300 is the height. So you can do multiple such operations on image. So you can even rotate the image by 45 degrees, whatever degrees you want to rotate it by. So let me run this. So rotated image, img.rotate. So these functions are very clear enough, like what their functionality will be. And then you'll have to pass on the degrees by which, angle by which you want to rotate this image. So let me just run this. So you'll have this rotated image over here. Okay. Similarly, you can, transpose the image and crop the image and do all sorts of other operations like apply some filter. So let me just run this everything all together. Okay. So in this case, I resized the image, I rotated the image, I flipped the image like it is horizontally flipped. I cropped the image like took only a portion of this image. Some text is written over here. You might not be able to see this clearly, but there is some text written over here on this image. You can adjust the font size of that text and all. So in this case, hello pillow, this particular text was written with fill color equal to red. So you'll get to know all this information in the pillow library's documentation. So you don't have to learn all this or memorize by heart anything. This is just an example or application of pillow library that I'm discussing. And then you can apply. So all this, I think, all these things are not discussed in your Swayam class, like the NPTEL class. So these are just some extra things that I am covering for your information only. Okay. So the crop, you can do all sorts of other operations as well. So if you go on to this tutorial, you'll see more examples here, like what all you can do with the Pillow library. And there are other sources as well which you can refer to for any detailed, tutorial on Pillow. Okay. So I'll just leave here like for this Pillow library discussion. Uh, in case you want me to discuss any specific part like which you did not understand, so please feel free to ask. Maybe we'll discuss it in the next session. For now, I'll just move on to the next topic in view of time. Okay, so the next topic that we are going to discuss is Turtle. So how many of you have used Turtle earlier? Turtle library? Is there anyone who know about Turtle library? Okay, yeah. So yeah, I think that's what we are here for, to learn what exactly it is. Okay, so in the lecture videos, you would have seen that the TAs have used a library called Turtle. However, Turtle is not directly supported in the Collab workspace. So for that, there is another library called Collab Turtle, which was developed by some developer. And then I'm going to use this collab turtle, but it has similar functionalities as that in the turtle library. So uh, there might be some little difference in the names of the functions, but the functionalities are more or less the same. So you won't find it difficult to understand what turtle does. Okay. So first of all, collab turtle is not by default installed in the collab environment. So you'll have to install it. So as we discussed in the last session, somebody asked about it, how you can use pip. So in the collab environment, you will have to use pip with exclamation. In If you are using it in terminal directly, you can simply use pip install collab turtle. So not collab turtle, any library name. However, you are using it in collab, so you'll have to use this exclamation over here to run any, terminal commands. So let me run this pip install collab turtle. So it will download that and install. Sorry. So it has installed some version of collab turtle. Now we can, import collab turtle as turtle. So I'm importing this turtle interface from the collab turtle as turtle. You can give any name over here, as you saw in the previous sessions. Like this is an alias for this entire thing. So instead of using collab turtle everywhere, I can simply use turtle. Okay. So instead of going through this, let me show you this particular simple example. So I'm importing collab turtle as turtle. So sorry, as t. You can even write turtle over here. And then I'm doing t dot initialize turtle with some speed. I'll show you how this is. And for I in range 3, first of all, I'm moving to right by 60 degrees. You'll get to know what's happening. Move forward by 100 steps, then turn right by 60 degrees, and then move forward by 100 steps. And let us see how it works. So this is a turtle. So it is moving right by 60 degrees, 100 steps forward, and then moving right, 60 degrees, 100 steps forwards, moving right, 100 steps forward, and then moving right, 100 steps forward. Okay, so what's happening over here? So if you are making it right, so it will move in the clockwise direction. Okay, and if you are trying to move it left, let me just write it left over here. So it will go to left, 60 degrees, move ahead by 100, then left, and then move ahead by 100. So in each iteration over here, it is moving to left, then moving by a certain angle, and moving forward in a direction, and then moving left again by that angle and moving forward. So in each iteration, you will get this triangle. Okay. So this was one thing that you will have to notice. Left or right will move in that particular direction. So for clockwise, you'll have to use right. For anti-clockwise, you'll have to use left. And then you'll have to specify the angle over here by which it has to move. Okay. And then t dot forward will make the turtle move forward by the given number of steps. It is very similar to Scratch. Whatever we saw in Scratch, it is the similar thing with certain functionalities over here. Like the function names are defined by the developer of this library. Okay, so is this particular part clear? How this particular shape, hexagon, was made? Is it clear, everyone? Yes, no? Okay, great. Yeah, is there any query?
Range doesn't have any value in here.
Which one?
Range,
Oh, range.
uh,
Range has three actually. Oh, sorry, I should have zoomed it. Yeah, range has three over here.
but it doesn't have any value here. You have moved 5 times.
No, we have moved this, so this particular loop is running three times. So this particular operations, whatever these four
Oh,
operations are there, they are happening three times. So in the first iteration, it is moving to by 60 degrees to the left and
oh,
then going ahead 100 steps. So it is rotating by 60 degrees, going ahead 100 steps, rotating by 60 degrees, going ahead 100 steps. So in one iteration, it is rotating by 60 degrees, going ahead 100 steps, rotating by 60 degrees, going ahead 100 steps. So this is in one iteration. So this is in
right.
second iteration, and this is
Oh,
in the third iteration. So that's
okay.
how it's happening.
Oh, thank you, sir.
Okay, great. So is it clear, everyone? Okay. Now there is something, yeah. So you can even color this particular, you know. So let me just define this list of colors here. So this path is by default white. So if you want to color it, you can even use this color. So list of colors, and I'll just see color, C equal to list of colors, I, and T dot color. I'm just passing C. So what's happening here? I have this list of colors. I have three colors. So I want to, give color to each iteration, like path in each iteration. So I'm just taking this list of color, adding three colors over here. So these three colors are inbuilt ones, like they are defined earlier. So once you pass this as t dot color, so you could have written turtle over here. So turtle dot color. So let us run this and how it looks. So you can see first it has become red. It has moved in one iteration. Now in the second iteration it has become green. It has moved, rotated, moved, and in the third iteration it will become blue. Move and then move. Now this will be clearer, I think, to anyone who did not understand what's happening in each iteration. Is it clear, everyone? Okay, great. Yeah, is there any query? Somebody raised their hand. Okay. Now, sorry. In this case, we saw that the turtle, as the turtle was moving, there was a path that was being traced here. Okay. Now, what if I want to, don't, if I don't want to, plot this particular path over here, like as the turtle moves. So for that, in the turtle library, there is a function called pen up and pen down. So it's similar to you're writing with a pen and then moving the pen up. So in that part, you won't be writing anything. And as soon as you move the pen down, it will start writing something. So let me just run this particular code. So turtle has moved ahead. Then there was a pen up. Then turtle has moved ahead, rotated, pen down, and so on. Okay, so what's happening over here? First, it turned red. Then it moved forward by 75 steps and then turned 60 degrees anti-clockwise or towards the left. Then there was a pen up, means the turtle just flew, kind of like or got elevated. And then it moved 75 steps forward without marking anything. And then it turned to the left by 60 degrees and then there was a pen down. Okay, and in the next iteration, it turned green and then followed the same steps as it did in the first iteration, and then so on. Okay, so this was a simple example of pane up and pane down functions in Turtle. Is it clear, everyone? Okay, I hope I'm not going too fast. At any point, if you feel like you did not understand, please feel free to interrupt and ask any queries you may have. Yeah, by default, it is pen down. But if you are doing pen up, you'll have to make sure that you also write the pen down whenever you want to pen down. Okay, great. So we can do lots of things using this sorry, not pillow, sorry, turtle library. So let me just run this code over here. So you can even, you know, make certain shapes out of it. So this is making a star. So what's happening over here? So there are four iterations. And in the first outside this loop, it's moving 75 degrees to the right and then moving forward, like turning 75 degrees to right, moving forward by 100 steps. And then in the subsequent iterations is moving by 144 degrees and then moving forward 100 steps. Here you can see there is one more parameter that I have added is initial speed. So if you keep it one, you will see that it will become slower. So let me run this. So it will run slowly. So every second it will move one path. Okay. Now let me make it 5. You see that the speed of the turtle also increase. So this particular parameter controls the speed of the turtle. You can write it in separate way as well, like I'll show you. So and there is one more thing that happened over here. So I just assigned this t, whatever this function t was there. We imported collab turtle as t. So I just assigned that to star, and I'm using now star as the function, the model, turtle model. Okay. So it is like assigning this alias to another alias. Yeah. So this was about making certain shapes out of it, and this code was given by the collab turtle developer. So before I go on to that, is it clear, everyone? What all we did with turtle library? When PaintUp is used, the coloring part stops. Yeah, so actually the coloring is still there, but it's just that PaintUp is not writing anything. So if PaintUp were not there, let me just run that code again. So let me just comment this out and run it. So the color is still there, but only thing is there was a PaintUp in that particular part. So if I comment this out again, remove this comment, let me run this again. So it will move, then there was a pen up, and it is not writing anything. But the color was there on Turtle. Is it clear, Naishal? Okay, great. Yeah. So I hope things are clear so far about this Turtle library. There are other functions as well. There might be certain differences in the functions used in the actual Turtle library and Collab Turtle. So yeah, please look into that. But the functionalities will be similar, like moving to the right or left by like turning to the right or left by certain angle or moving forward, backward, and so on, or pane up and pane down. Okay, so here is a detailed code that the developer has given. So this is quite interesting. So I just thought of like running this simply in the class in this session. So let us run this and see what's happening here. So it's like a pretty uh, good example of what all you can do with the turtle library. So it's just trying to write something. So you can see turtle is moving in certain direction and then writing something. And yeah, that's it. So you can do all sorts of animations with this turtle. uh, library. Yeah, so this was just an example. You need not again remember all these things. This was just to give you a demonstration of what all you can do with Turtle Library. Okay, so what kind of questions you may expect in exam? So you will be given like, certain shape. So you will be asked like what code will produce this kind of shape. Or you'll be given a code and then you'll be asked like what kind of shape this particular code will, output, and so on. In regular turtle library, you won't see this turtle as such, but in collab turtle, they have also added this turtle shape over here. Okay, so these are the kind of questions you might expect in your exam. Okay, so there is another library called Collab Turtle Plus, which has even more functionalities. It can do some parallelization, like two turtles, or one or two turtles, two or more turtles can work at the same time. And yeah, this is just an example. So you need not remember this again. This is just an exact extra information. And there is this another thing. So you can see that two turtles are moving and creating two different shapes. Yeah, so you can do all sorts of things with this data library, Collab Turtle Plus. So this is just for your information. Not this won't be asked in the examination. Okay, so moving to the last part of the session, which is GM plot. We'll skip the CSV library part because it's not that important. We saw it in one of the previous sessions as well. So it is simply used to, read the CSV files and extract certain information out of it. We'll see it in more detail when we discuss Pandas library, which is used to, read data frames. So please wait until that. But basic application of CSV library is to use read CSV file and extract information out of it. Okay. gmplot is another library um, which you can use to add certain markers to Google Maps. So let's say you have some city and you want to, uh, put a marker or on a city or on a location using Python code. So for that, you can use this gmplot library, or you can even use a list. So in this case, let me just show you quickly what's happening here. So I'm importing gmplot, then I'm using this gmplot.google map plotter. In this, I'm passing the latitude, the longitude, and the zoom value, like to what zoom level I want to see that. And then it will create an object which you can use to create an HTML file. So let me just run this quickly, and it will create an HTML file here, map1.html. Let me just download this and run it, open it. So I'll save it in my system and just open it. So it will throw an error that this is, so I think it needs some paid subscription or API. So you won't be getting this for development purposes only in the paid subscription, I think. I believe. Sorry, I'm not sharing this. Yeah. So, but I'm getting this particular location called Dehradun. So these are this particular latitudes and longitudes are for this location Dehradun. Okay, and then this 13 is like the zoom level that I'm having in this particular map. Okay. So let me show it to you on this Geeks for Geeks page. So they have given multiple examples here, which will make it clearer. So you are importing gmplot. Is there any query? Yeah, somebody is on unmute. Please mute yourself. Uh, okay. Yeah. So you're importing gmplot over here. You're passing this latitude, longitude, and the zoom value, and then you're saving this. You're storing this in a map object which you can store as a or save as a HTML file, which can be viewed in your browser. Okay. For those of you who do not know what HTML is, HTML is hypertext markup language, which is used and for developing your for the web development purposes. So whatever websites that you see has HTML code as source. So if you just go on and then see the page source over here, so you'll see all sorts of for this particular web page, you'll see all HTML, JavaScript, and other codes. So let us not go into this now. Yeah, so it will give you an HTML file which you can open in your browser, and it will show you this particular image of the map or whatever you have plotted over here or pointed over here. Okay, so this was one, and also you can take it from the geocode. So this is only available, I think, for the paid subscription, or I'm not sure, like if you need a because it was throwing some error that it needs some subscription or you need to import some API. So or connect to some API. Yeah, you'll get to know when you try this out. Okay. So there are for certain cities, the names are also predefined. So you can even instead of passing this latitude longitudes over here, you can even pass the name of the city use in this from geocode function. So in this case, you are using only gmplot.google map plotter. In this case, you are using gmplot.google map plotter dot from geocode. Okay, in the example that was shown in the lectures, a lot of latitudes and longitude values were taken, and they were used to map a path, mark a path on Google Maps. So that was the information was there in the CSV file, in which each row contained a latitude value, a longitude value, and then those values were used to put markers on this map, and then a kind of path was made. Okay, so yeah, you can do all sorts of things using this gmplot library. So in this case, you can see that there is a path that was drawn over here with the latitude list and longitude list. So in this, there is this, they have defined this latitude and longitude list, which has three latitudes and three longitudes. So each has there is a latitude longitude pair. And once you plot this, so the scatter will scatter these 3 points, X and Y, let's say, coordinates on this particular map, and then this plot will join them all together. Okay, so this is another example, and there are multiple such examples that they have given in this GM plot. So there are like multiple latitudes and longitudes over here list, and then you are trying to plot all these latitudes, longitudes. So it is not so clear, but you can see that all these latitude, longitude pairs are plot on this uh, particular map. Is there any query? Okay. So yeah, you can even highlight a a range. So there are these three latitudes and longitudes. They have been plotted over here on the map, and then you can just make a polygon out of it, and then highlight that particular region. So you can do all sorts of operations. So this was all about the GM plot library. So this was just an example that was given in the lectures that you can read data from CSV files. So from the CSV file, you are reading this information, the latitude and the longitude, and then using that to plot markers on the Google map using GMplot library. So that was the simplest example that was discussed in the class. Okay, so I hope this is clear to everyone. Any queries? National, is it clear or not? Sorry, I didn't get what you said no for. Okay, great. So we'll discuss some questions now. Uh, Let me go back to slides. So yeah, here is a question. Which of the following is or are uses of functions? Okay, yeah. So you can select only one option at a time. So yes, yeah. So functions, they obviously make the code reusable, gives a higher level overview of the task to be performed. Like for example, I have defined a function factorial. So I know this particular function will do factorial task. I don't know what's happening inside, but I can say from the function name that it is computing the factorial of a given value. So that gives you a higher level overview of the task to be performed. It gives you ability to reuse the code, same code again and again. You don't have to write that same piece of code again and again for every input value. And then a better understanding of the code because it makes the code cleaner. Writing function, you don't have to write everything again and again. So that will also give you a better understanding of the code. So yeah, all of the above are the correct option. Is the correct option. Okay. So this is something about information. So which of the following library moves the turtle backward? So actually, the correct answer is all of the above because if you go to the turtle documentation, let me go here. So yeah, you will see you can check in the library, like library's documentation, what all values are there, like sorry, functionalities are there. So yeah, so for forward, it's for FORWARD and FD. For backward, it's backward, BK and BACK. So these three things are available. I'm not sure if this was discussed in the class, but this is just for your information because this question might have been in the one of the previous offerings of the course. So that's why I've added it over here. But just in case this kind of questions are asked, you should be prepared. Okay, so which of the following library has to be imported to plot the route map using GPS locations in Python? So this is again straightforward. We just discussed it. It's gmplot and CSV. Sorry. So the question answer over here is not so well formed. Actually, in the lecture, they have used CSV as well as gmplot to perform this operation. So that's why this question was like little ambiguous. But yeah, if gmplot is the only option that you have without this both, then it would have been the correct answer. But CSV, they used it to read the file data from the file and then plot it using gmplot. So that's why both are correct here in this case. Yeah, so this is some uh, application of dictionaries. So you can do it at your own convenience later. So what is happening over here? So this is a snake ladder game, and then the ladder positions are given here. So this has been initialized as a dictionary. So what is happening over here? So this is the starting position of the ladder, and this is the ending position of the ladder. So I assume all of you know what snake ladder game is. So each value over key value pair over here represent the starting position of a ladder and the ending position of the ladder. So the snake positions are not given. So snakes, if snakes were there, then there would have been like another dictionary that you could have initialized with the snake's position, like the initial position of the snake and the end position of the snake. Okay, the head of the snake and the tail of the snake. So dictionary is used over here to define the starting and the end position of each ladder. And the question asks that what is the least number of times a player has to roll a die with the following ladder position to reach the final stage. So you'll have to, based on this particular ladder position, it is just a simple computation that you have to do by hands. In examination, you don't have to write a code for that, but this is just an application of dictionary that they wanted to show. So you can do it at your own convenience. The answer over here is 5. So you can just ignore that for the time being and just try it out later. Which of the following code snippet will create a tuple in Python? So yeah, we did not discuss tuple in detail, but we'll surely discuss it in the subsequent lectures when we'll cover what tuples, sets, and lists are in detail. Okay, so the correct answer over here is uh, parenthesis. The second option is set, and then this is a list. So you should be careful about this. So the parentheses are used for tuples, curly braces for set data type, and then square brackets for list. Okay, so here is a tricky question. What does the following program plot? So take some time to think over it, and we'll discuss this in detail in the next lecture or next class. So I'll leave it over here. I'll share this PDF as well in the folder, shared folder. So yeah, so some of you got the answer, Sims. So sorry, for those of you who need some more time, please think over it. I'll share this PDF as well in the shared folder so you can go and solve it at your own convenience. So yeah, that's it for today's session. So I hope it was useful and you learned something. So yeah, thank you for joining, and I'll end the call here. Are there any other queries? Yeah, Mr. Mastan Sheikh has asked, fib of numbers are 0, 0, 1, 2, 3, 4, but fib of 5 is fib of... so this 5 is actually the position 5. Yeah, so position 5, it all depends on how you consider that. So if you are considering this 5 as an index, so it will be starting from 0. But if you are taking it as a position, then it will start starting from 1. So it depends on the kind of definition of that 5, like the input that you are taking into consideration. So fib of 5 is fib of 4 plus fib of 3. So if it is a position, so it will, the first position is 1, 0, second is 1, third is 1, fourth is 2, fifth is 3. So fib of 5 is 3 in that case. If it is index, like if you are taking it as an index of the array, so then fib of 5 will be sorry, fib of 5 will be 5, and then if it is position, 1, 2, 3, 4, 5. Sorry, I'm making confusion. I'm creating confusion. So if it is position, it is starting from 1. If it is index, it is starting from 0. That's it. Sorry for all this mess. Yeah. Mastan, I hope that is clear to you. Yeah, thank you, Leela. So, Raviraj, is there any query? Okay. I hope you understood everything. So please let me know if you have any queries. We'll discuss them in the next session in detail. Okay. Thank you so much everyone for joining. And yeah, let us meet next Friday.